incremental development. So this really gets into the issue of software development. Was something up there before? No? Oh, okay. Okay. Not sure what happened here. I thought I had put this all together. Well, we'll get more. Okay. And folks say for weeks to 5 weeks, something like that. It was facetious in the fact that it's very hard for people to estimate. And since that, since that point, there have been many inroads, many advances to lessen that degree of variability. One of the biggest ones I'm going to be talking about today in the next half hour or so, okay? And that has to do with the broader notion of incremental development, and in particular, a form of incremental development called test-driven development, which not only has the virtue of iterative delivery, of sort of delivering things in small pieces, but also brings to bear the benefits of making sure that tests are thought through very clearly, the testability of the code, the ability to test it, the ability to make sure it's operating correctly, that's emphasized, and such that we have a large suite of tests that we can run at any point to help ensure quality. This is in response to a previous tendency to use what was called the waterfall. Okay? And you'll hear this term now. It's often used as more of a straw man than an advocated type of development. But the idea is in older times, you'd find that there was a real tendency to say, okay, look, we're going to build this software program. Let's go find the requirements for the software program. You go out and talk with the potential users, you talk with customers, what it is you need. You sort of sit through and sift through those things for what really needs to be done. You think through the implications of that in the technology side, the so-called derived requirements, and then you go about planning how you're going to do that. And you end up creating an architecture or a design, and you end up working towards that design. Now, this all sounds great. After all, you want to think about where you're going before you start out. But the problem is that often this was done on large pieces of functionality. So someone would say, I want a human resources management system for my company. And these are the functions it will have. And so they end up, when they end up going and getting these requirements and so on, it's a lengthy process. That might take 6 months by itself. And then you go and you do the architecture design another 6 months. And then you go about starting to implement it, and that takes 1.5 years or 2 years. 2 years later, after development started, maybe 2 years after the whole thing comes, the developers come and they say, here's your system. And the folks over in HR say, that isn't what we requested. No, you misunderstood this point. And oh, man, we stopped doing that 2 or 3 years ago. Now we've merged with this other company and we need to do all these other things as well. And man, I hate how you're displaying, look at those colors. They're ugly as sin, and not only that, these days, look, today's a mobile technology. You can't deal with a web interface only. I mean, everyone and their brother and sister have a smartphone these days. Let's go get a mobile side. That's much more important now. And developers, it's an exercise for frustration. The developers get frustrated. They say, wait, we built what you told us to build. And, here it is. We've been working our butts off on this thing, often overcoming all sorts of technical obstacles and confusions and design issues, etc. And you tell us it's no good. On the user side, they say, who are these folks? What sort of value have they delivered to us? They dream up some techno fantasy and it's very little to do with our needs. And so this is disconnect. Sometimes the project's canceled. Sometimes it goes back to the drawing board and they have another 1.5 years before value is delivered. These are not sort of myths. These are real things that happen. They continue to happen, ladies and gentlemen. You could go read about the Westpac banking system, for example, as one of the most egregious examples of these things. So people realize this general strategy of sort of getting requirements, sitting back, planning things out, going and incrementing, going and delivering and implementing and bringing it to the user after a long period of time just doesn't work. People's memories are off, often it's not the same people you bring it to at the end. And needs evolve. So to help deal with this, the field recognized that this sort of big bang model where we go and work for a long time and then boom, we bring the user our big system. It doesn't work so well. Instead, it's better to incrementally build it up in a way that at every point, the user is comfortable with what you're doing. They get a chance to see it. They get a chance to give feedback. Often, ladies and gentlemen, this sounds strange, but it is incredibly deep truth. People don't really know what they want until they have something concrete to look at. Something that they can kind of poke and get a feel for. That makes them really reflect on, now that I think about it, now that you've shown it to me like that, what I really want isn't what I originally said, but this other. So here, with this incremental development, we're trying to get something in front of the user as soon as possible, and in fact, deliver value to the user as soon as possible in a prioritized fashion. Okay, what is it you need most? Let's make a step towards that, see if it's working, get your feedback, let's make another step, and let's do so step by step, rather than holding off and delivering a system that may be totally misaligned at the end, okay? So, in this class, you've been given very defined assignments, restricted, focused on a particular area, fairly well specified. Real-world situations don't share these characteristics. You're working with users who have no understanding of what the technology can do, and some having thought through some of what their needs are in light of what's available technologically. And you have developers who often aren't so familiar with what's needed either, the domain of the user. So the whole notion of iterative software development has to do with a nimbleness of quickly delivering value. Often it makes key use of prototypes to sort of sketch things out to get user feedback. Storyboards, as they're sometimes called. And you pursue it in a series of small steps that always deliver value and always get user feedback. So incremental development as a general discipline involves some areas of where we're going in the next little bit. This may be 1 week, this may be 3 weeks. Here in town, there are some companies that have cycle times, as they're called, of a single week or 3 weeks. They try to get something in front of the user that quickly. So we're not talking months, we're not talking years, we're talking weeks, sometimes days, or 1 week. Okay, you have an iterative step, you get feedback from the user and redesign, and you will then sort of get value delivered that the user can actually use, get further feedback about what's next in terms of priority, and you loop back to an iterative step. So this is particularly effective with smaller teams. It is being applied in some cases by larger teams with appropriate extra care. And generally it leads to a more reliable understanding of user requirements. More importantly, it also leads to the user getting something early on. Sometimes the user gets so disgusted with the long wait, they decide towards the end, we don't even want this. Believe me, I've seen it. I've been called in as a consultant for large companies where exactly that has happened. The client is just so disgusted, they say, we don't want this anymore. And you can adapt to changing requirements along the way. If the company gets bought out halfway through what the original project would have been, you can adapt to that situation. And it is something which leads to greater morale all around. Okay, so there is a special role for prototyping here. Prototyping involving very rapid, throwaway investigation of certain issues. Often these are the issues which are risks. You're not sure how you will do something. You're not sure exactly what's needed. You're not sure the user seems really uncertain about what they want for something. So you don't need to do a prototype. A prototype is not the product. A prototype is sort of to your program, sort of what a clay model of a car or a building is. You know, a small bridge like they'll build in civil engineering, small model bridge, to give you a sense of what's needed, like an architectural mock-up to someone who's going to buy a large house. It's not the house, but it gives them a strong enough sense of what it will look like to make sure that it's what they want and to get their feedback. So a prototype is a throwaway component, but it allows us to deal with these risks, to identify the risks more clearly and explore different ways of resolving them. Okay, so it's quick and dirty, and you get a loop done. Prototyping is part of this process, but the thing I want to focus on today is test-driven development. And I asked you to, and I think I was told by one of the class members, the first of these is no more. First of the videos is no more. But I did ask you to take a look at some videos on test-driven development so you could get a leg up on the assignment. Test-driven development, often called TDD, has a couple of principles. So the first, as suggested by its name, don't write a single line of code until you have a test in place that fails. If something the code is trying to achieve beyond the current functionality, something that you have a test for that's not working now, so you know it is needed. There's a principle that sometimes goes along with this, the Gagny principle. Does anyone know what that stands for? You ain't gonna need it. Don't do something unless you're confident that it's actually needed. One of our failings as software developers is often we get so eager about what we're doing, we end up embellishing it, put all sorts of extra things in it that really aren't needed for the user's interests, and sometimes at all. Believe me, we do that. We love writing code. So we go and more code. Oh, we really need if it did this. And one of the principles that's embedded here, and that first one, is look, if there's not a test that fails, if there's it needs to do that it's not doing now, don't go and start writing lines of code. And make sure you know where you are going to address this test, for example, or this set of tests. Okay, don't write more being a test than is necessary to fail. Okay, so keep yourself driven, sort of meet these needs by, if you have a test that fails, go off and make sure the program can deal with it. Don't embellish the test a great deal. And don't write more code that's necessary to pass the fail test. Now, I'm going to put an asterisk after this, because sometimes you write the code, it's not just dealing with that one case, it's dealing with a broad set of cases at once, okay? But the point is you want to keep that constraint. You don't want to go off and embellish it in huge numbers of ways. But, you know, if it currently won't handle -1 past the square root, you put in place a mechanism that may deal with negative numbers. Okay, and then it passes the test. You don't deal with just -1, just -2, right? Okay, so the basic process here. The first time I put this slide up, I realized there was a bug in the slide. So here we create the test module will contain the test. This is the thing that contains our so-called test harness or test scaffold. The thing that's going to call on to our code to perform the test. And then we create a stub, a so-called stub, sometimes called a fake, particularly in the object-oriented context, for the thing that we're trying to test. So if you have a square root, and you start a function, and you're starting from scratch, you might have a function that takes the right arguments, but it just returns 0. and it just returns some dumb value. This is a stub. Ladies and gentlemen, if you're building systems, often we stub things out so that we build other parts of the system that will work with this, and we'll come back and fill this in. Okay? So we have to be careful to sort of, if A depends on B, and we're working on A, and we want to be able to run some tests involving A, we want to be able to call something, and so we may have a little dummy version of B. Okay? That's a stub. That dummy version of B is a stub. A calls off to the stub instead of the real version. Okay? We then write a test of functionality that may not work. When I say may not there, this is often a little bit embellished from the normal way you see this, because sometimes you're not sure if this will work. Sometimes you're not positive if the code will work. So you write it for this functionality that often you know, you're very sure it won't work. Sometimes you just suspect it may not work. And you see if it passes. If it does pass, ladies and gentlemen, you go back and you write another test. This test already works. Great. Go back and write another test. Sometimes that's not clear though. And it will work. But in many cases, in most cases, in almost all cases you'll be dealing with, it obviously is not going to work. Okay, so write enough of the code for that test to then pass. Okay? Okay, are there any other things this code should do? When I say functions there, I mean any other jobs this code should, any other tests that you might run? Does it need to handle different types of numbers, for example? If so, go back and write tests for those. Keep on iterating. You're building up this code, and you're building up the tests for the code interactively. In an interwoven sort of way, okay? And of course, at some point, you think, wow, this is tested basically all the cases I can think of. It's tested those boundary cases. It's dealt with those equivalence classes. I tried it with some cases I really wasn't sure it was going to work, and it's performing correctly. Then you'll declare victory and be done with it. So test-driven development involves this interweaving of, on the one hand, testing, test building, test case building, testing it on particular cases, and on the other hand, extending that code. Does that make sense to people? Are there any questions about this process? Okay, you've seen a couple of videos on this as well, so hopefully that's a reflection that you're feeling comfortable with it. With respect to test-driven development, there's often a set of stages. I mean, you want to have some idea of what it is you're trying to do, and some idea of sort of the types of data you're going to be dealing with, and then some tests that will demonstrate whether or not this code works, okay? I was going to talk now about a program template, but my thought would be because we have limited time for covering two topics, to actually, having given this basic introduction to test-driven development, to basically go and hit our other major topic today, which is subversion and version control. Okay? Why am I communicating this with such urgency? Why not spend more time? Why not do the material we'll present on Thursday now instead? Well, it's because the lab for this afternoon and for Thursday does depend on use of subversion, and I want to communicate that. It's also a technique that you might want to use immediately for your assignments, even on your own, okay? So I'd like to talk about these things. Any questions on test-driven development and that methodology before we go on? So let me ask this, where am I building up the test? If you're talking about this whole process, I want to ask you some questions. Folks, where am I building up these tests? Where's tests being added? To where are these tests being added over time? They're being added to what? Yeah, to the testing runs, to the scaffold. So I'm going to have some function. You could call it main. For example, it might be a name, right? And maybe in main, I'll have a section of code, like you could have an if-def around it, if-def testing. Who can help me understand what this means? If-def testing. What does that mean if I have if-def testing? There's a space here. Yeah, exactly. So basically this says, hey, if this macro called testing is defined, then actually it will pay attention to what's in here between this if-def and this end-if. If testing is not defined, it won't pay attention. How could I define testing? How could it? Under what conditions would testing here, this if-def testing, under what conditions would it know about testing? Under what conditions would it actually process these things? Give me one case. If up here I had a undefined testing, testing to be, for example, 1, that would make it compile. There's actually another way to do it, folks. When you compile a GCC, there's a flag for GCC. One is the flag that allows you to make sure this is defined. Then you don't need this defined testing to be 1. Instead, you can do -de. I think this is the syntax on it. I think you may be able to also assign it, but this is quite explicitly here. But you can tone out there. Testing. So you can have a situation where you can, as when you're compiling your code, you're compiling main.c or whatever, you can tell it treat testing as defined, and then pay attention to this area. Okay. So in here, you might have various steps with using, say, assert, right? Assert square root of 4.0, equals, okay, this is going to be hazardous. I wouldn't, I'll leave it as if that's it, but actually you want to subtract from the test if it's less than the absolute value, if it's less than some small difference, because this might not be exactly 2.0, might be 1.9. Probably like maybe I won't. So you could have a bunch of these tests here. And if testing is defined, if we're in testing mode, if this program has been compiled to be tested right now, these tests will be processed when we run main, otherwise not. Does that make sense? Test harness, test scaffold. Okay? Or you might take this out and you might put it in another routine, another function called, test suite, something like that, and you might then have, a call to test suite from main if tested defined. Okay? Does that make sense? Okay. Any questions on this? Any questions on pointers that people want to ask? Yes.
Based on the assignment that you
Yeah. Okay, so I can't remember if it stipulates that it has to be a fine.
Yeah. Here, based on the TDD, for each function, we should go through the whole
Correct.
assessment.
Correct.
Okay?
Correct.
So for each function, we should do all of it.
Yeah, then in that case,
After the main, we should do these.
Correct.
I'm a little bit confused that we should do that part of the process that we do.
So the point here is these tests write a test for functionality. What this does not specify, so this is a great question. What's not specified in this slide is right here. It says write a test for functionality that may not yet work. Okay.
For example, we have a function.
Yeah.
Like add.
Add, yeah.
Okay. So for this one, we should write a test.
Yeah.
A
fake test, a test of that function. You start with the stub of it, and you would then write a test for it, verify it fails, and then go back and expand that stuff. Right? Uh-huh.
And based on this process,
Yeah.
you create the function.
That's right. So the function, add vector, what have you, will be built up over time to capture the functionality needed by tests. And where are those tests being added here? They're being added here.
So that would be, I think maybe every 20, 30
Lines.
a lot.
That's right. That's right.
We should bring all of them.
Well, okay. For this assignment, yes. In general, when we're building test suites, they're not going to live in main. They're going to live somewhere else, and we'll call them maybe for main. But the point is, when you run your program under a test code, you want it to somehow go off to that test suite, right? And for simplicity, we had to put it in main right now. You know, if you folks are in my class in 371 and you come from 370, what you'll see there is when we have a class, let's say, that has to be tested, we'll actually often associate the test for that class. We'll put those in the class so that they're not just all, you know, not all tests are placed in the same big bag of code. They're placed with the thing to be tested. And to answer your question, you know, we might, for example, if we have addVec, we might have an addVec test that would be a kind of nicer place to put those tests. But trying to simplify your lives by having you put them all in one place and not have to worry about that level of organization right now. Does that make sense? Because, you know, we could have an addVec test, and then we could have a extendVec test, and we could have a allocateVec test, or what have you. Okay? Good question. Other questions? Yes.
If we were inclined to go crazy with organization, would it make sense to put the test perhaps in a different file entirely?
Yeah, you could do that, although generally speaking, you probably want to keep, so C programs are decomposed into modules, .c files, often which are associated with associated.h files that give the signatures of the functions and the contracts. It's nice to keep the test near the thing being tested, so I wouldn't, you could have a test C module, you know, okay, foo.c, foo.test.c. One advantage of that is that you could simply omit those tests via linking, you know, at the time that you're creating a program that is not test version program to be given to the user. But often it's beneficial to have the test nearby the code because you can actually quickly go between the code and tests and so on. So I'd be a bit hesitant with that, but it's not bad. In general, you're absolutely right. You know, having all the tests in one place it gets really messy quickly. And that's why, you know, professional development would break them up into methods and functions. It's just not required. Okay? But, so those are, putting in other modules, yes, you can do it, but I haven't seen a lot of that in my time. They're often closer to the code being tested. Other questions? Yes?
Should our fixed precision of floats exist only when they're testing, or should we apply it to the whole?
The fact that floats are of fixed precision, you're saying?
Yeah, I thought the fixed precision should be fixed.
I see. You don't have to apply it to the whole program. Okay? That would complicate your life in some places, so that's not something that's required. Okay. Good question. Okay, other questions? No? Okay. Okay, so that's the issue of test-driven development and some comments on the practicalities of testing. I'm just going to stop.